Good evening to all. Am I audible?
Yes,
Good
ma'am.
evening, good evening.
Okay. I'm going to start my lecture 3. I hope screen is visible to all of you.
Yes, ma'am.
Okay, so I'm going to start lecture 3. That is about transmission electron microscopy. So in last lecture, I was discussing about scanning electron microscopy. So where you have learned how with the help of scanned electron beam, we can have the information about the surface. And now in this technique, this beam will be transmitted to the surface, and from there we can collect the information about the surface. So outlines of today's lecture will be as following. First, I will be discussing the concept of resolution, then introduction to TEM, principle behind TEM, instrumentation, how it works, and working of TM, and the similarities and differences between scanning electron microscope and transmission electron microscope. So first is the concept of resolution. So the smallest distance between 2 points that we can resolve by our eyes is about 0.1 to 0.2 millimeter. That much we can resolve very easily with the help of our eyes, depending on how good our eyes are. So this distance is the resolution or resolving power of our eyes. The instrument that can show us pictures revealing detail finer than 0.1 millimeter could be described as a microscope. So the Rayleigh Criterion defines the resolution of light microscope as, that is delta equal to 0.61 lambda mu sin beta, where lambda is the wavelength of the radiation, mu is the refractive index of the view medium, and beta is the semi-angle of collection of the magnifying lens. So the variable of refractive index and semi-angle is small. Thus the resolution of light microscope is mainly decided by its wavelength lambda of the radiation source. So taking green light as an example, so here one example is given. Suppose we are having this wavelength, that is 550 nanometer wavelength, and it gives resolution of 300 nanometer resolution as per this formula. So which is not high enough to separate two nearby atoms in solid materials. So the distance between two atoms in solid is around 0.2 nanometer. So we need to have some advanced techniques by which we can see the atoms at this level. So that is why there is need of resolution, more magnification, so we can easily observe atoms at atomic level with the help of this technique. So when electrons are accelerated up to high energy levels, that is few hundreds kilo electron volt, and focused on a material, they can scatter or backscatter elastically or inelastically, or produce many interactions, sources of different signals such as X-rays, OG electrons or light. Some of them are used in transmission electron microscopy, just as in case of scanning electron microscopy. So when electron beam interacts with the surface of the specimen, several interactions takes place. So elastic scattering could be there, inelastic scattering could be there, and there are many other signals like X-rays are produced, light is produced, OJ electrons are produced. So from these signals, we can have a lot of information in terms of surface. So in transmission electron microscopy, the electrons are accelerated at high voltage, that is from 100 to 1000 kilovolt, to a velocity approaching the speed of light, 0.6 to 0.9 c. They must therefore be considered as relativistic particles. So the associated wavelength is 5 orders of magnitude smaller than the light wavelength. So light wavelength is given here in this bracket, 0.04 to 0.008 angstrom. So the magnetic lens aberrations limit the convergence angle of the electron beam to 0.5 degree instead of 70 degree for the glass lens used in optics, and reduces the TM resolution to the angstrom order. So we can have resolution, this much resolution with the help of TM. So this resolution enables material imaging and structure determination at the atomic level. So at the atomic level, due to this resolution of angstrom order, we can have imaging and structural determination with the help of transmission electron microscopy. So in SEM also I have discussed this particular diagram. So suppose we have sample, an incident high electron beam is there. So in case of SEM, it is just scanning the surface, but in case of TM, it is transmitting into the surface and collecting the information. So we can have various signals depending on the interaction of incident beam and sample. So we can have the secondary electrons, we can have these backscattered electrons, and I have already discussed the differences between these. And characteristic X-rays could be there, OJ electrons could be there, visible light, Bremsstrahlung X-rays, elastically scattered electrons, inelastically scattered electrons, or beam can pass directly also. So when an accelerated beam of electrons impinges upon a sample, a rich variety of interactions takes place. The interaction that occur during the collision of the electron beam and the sample include directly transmitted electrons. Some electrons may transmit directly. Backscattered electrons, secondary electrons, coherent elastic scattered electrons, incoherent elastic electrons, incoherent elastic forwarded scattered electrons, characteristic and continuum X-rays. So I have already discussed the difference between characteristic and continuum X-rays when I was giving the lecture of X-ray diffraction. OJ electrons, which I am going to discuss in next slide. Long wavelength radiations in the visible, ultraviolet and infrared regions of the spectrum. Lattice vibrations, they are basically phonons. And electron oscillations in metals, electron hole pair generation, electric current. So in principle, all these products of primary beam interaction can be used to derive information on the nature of the specimen. So basically we derived so many information with the help of these signals. So OJ electron must be new word for you. So I am just trying to explain you with the help of this diagram. So when the higher energy electrons fills the hole, suppose this higher energy electrons fill some hole. Suppose the electron is going from K to L shell, and then from L to K shell, it is just filling the hole. Then the release of energy is transferred to an electron in an outer orbit electron. So when electron is coming back from L to K, some energy is released. And if this energy is transferred to an electron in outer orbit electron, then electron has sufficient energy to overcome the binding energy and work function to be ejected with a characteristic kinetic energy. So what will happen? This electron will be ejected from there and it will have its own characteristic kinetic energy, and from there we can have this analysis. So that the ejected electron is termed as OJ electron. Thus OJ process requires 3 electrons, so we cannot detect hydrogen and helium. So in this diagram it is shown here. Suppose incident electron is hitting this K shell electron and this is ejected from there, and at the same time one electron from L shell fills the vacant position in K shell, and the energy which is produced in this process, it is imparted to the other outer shell electrons. So this electron is termed as OJ electrons, and it has its own kinetic energy, and with the help of this kinetic energy we can have this analysis. So I am moving further towards the principle of TEM. So transmission electron microscope operates on the same basic principle as the light microscope, but instead of light it uses electrons. Because the wavelength of electrons is much smaller than that of light, the optimal resolution attainable for TM images is many orders of magnitude better than from a light microscope. That is why we prefer to use electron microscope to have this atomic level analysis. So among all microscopes, both light and electron microscope, TM are the most powerful microscope used in laboratories. It can magnify a small particle of about 2 nanometer, and therefore they have a resolution limit of 0.2 micrometer. So this much analysis, at this level we can have analysis. That is why TM are widely used. So I am moving towards the instrument of transmission electron microscope. So it is having 3 parts. So I am going to discuss one by one. So the electron column, because since we need electron source, so we have this electron column consists of an electron gun and set of 5 or more electromagnetic lenses operating in vacuum. So just like in case, say Sem, this also operated under vacuum only. So it is convenient to divide up the TEM into 3 components. So there are 3 components. First is illumination system. It takes the electrons from the gun, it means from the source, and transfers them to the specimen, giving either a broad beam or a focused beam. In the ray diagram, the parts above the specimen belong to illumination system. I will show you the diagram in further slides. Second part is the objective lens and the stage. So this combination is the heart of TM, which I am going to show how. And third is the TM imaging system. So physically it includes the intermediate lens and projector lens. So I am discussing one by one. So first is the illumination system. So the illumination system comprises the gun and the condenser lenses, and its role is to take the electrons from the source and transfer them to the specimen. So illumination system has very significant role. It takes the electrons from the electron gun, obviously, which is producing this electron beam, and it transfers to the specimen. The electron beam is accelerated to an energy in the range 22,000 kilovolt in the electron gun, and then the obviously high voltage is used there to produce the energy in this range. Then the electron beam passes through set of condenser lenses. So in illumination system there are several condenser lenses in order to produce a beam of electrons with a desired diameter. The second part is objective lens and stage. So the objective lens and the specimen holder oblique stage system is the heart of the TM. Here is where all of the beam specimen interactions take place. So the diagram which I was showing you before between electron and sample interaction, electron beam and sample interaction. So that interaction takes place here. So here is where all the beam specimen interaction takes place and several signals are produced, and the 2 fundamental TM operations occur, namely the creation of the various images and the diffraction pattern that are subsequently magnified for viewing. Two important operations also takes place, that is the creation of various images from our specimen, and the diffraction pattern is also formed from this data. So third part is TEM imaging system. So the imaging system uses several lenses to magnify the image or the DP produced by the objective lens, and to focus these on the viewing screen or computer display by a detector, CCD or TV camera. So here all the things are there. We are having this computer display is there, detector is there, CCD or TV camera is there. So images are recorded on a conventional film position, either fluorescent screen is there, position either below or above the fluorescent screen, or digital capture can be utilized using CCD or TV cameras, so which takes the picture of these images. So this is a typical diagram of TEM instrument. So we have this electron source, electron gun. From there we have the production of electron beam. And this is the first part, that is the illumination system. So it has this condenser lens. And this is the second part, which has this objective aperture lenses, and where the specimen and electron beam interactions take place. And the third is the imaging part. So this is these two parts are the basically objective part, and the third one is the imaging system, where projector lenses are there and fluorescent screen is there where our images are formed. So I'm going to discuss how it works and which signals are produced. So the diffraction pattern, that is DP, and image are formed at the back focus plane and image plane of the objective lens. If we take the back focus plane as the objective plane of the intermediate lens and projector lens, we will obtain the diffraction pattern on the screen. It is said that the TM works in deflection mode. If we take the image plane of the objective lens as the objective plane of the intermediate lens and projector lens, we will form image on the screen. It is the image mode. So there are two modes basically. One is diffraction mode and one is image mode. So we can work in both. So it works in diffraction mode and first it works in diffraction mode, and if we take the image plane of the objective lens as the objective plane of the intermediate lens and projector lens, then image will be formed on the screen and then it will be considered as the image mode. So there are two modes. First diffraction pattern is formed, that is your diffraction mode, and when its image is formed, that is our image mode. So how does a transmission electron microscope work? So first remember, we need to have some sample preparation before we start our experiment. So sample has to be very thin in case of TM because we have to pass a beam of electron. So sample has to be very thin and it has to be in vacuum. Whatever measurements are there, it has to be done in vacuum. So a transmission electron microscope is a large piece of scientific equipment that forms detailed images called micrographs. So in scientific terms, we can call those images as micrographs. Specifically, transmission electron micrograph of extremely small objects or areas of objects by passing a beam of electron through a very thin slice of the area of interest. So TM consists of a cylindrical tube about 2 meters long. The tube contains a vacuum. Vacuum means there is no air or other gas inside the part of the tube where the specimen is loaded, where we are having our sample holder or we can say specimen holder. So this is because molecule of gases such as those in air absorbs electrons. So TM works by emitting electrons from a cathode, then accelerating them through an anode, after which the electron pass through an aperture into the vacuum tube where we have our specimen. So after following this process, as it passes down through the tube, the electron beam is controlled by the electromagnetic lenses formed by coils around the tube, whose effect is moderated by adjusting the electricity flowing through the coils. So these electromagnetic lenses direct an electron beam through the center of the tube to a very thin specimen located part way down the tube. So if you see this diagram again, so this process is just going on here. From electron beam is produced, and after from this illumination part, it goes to objective lens part where we have our specimen, and vacuum is there always. So we have this sample and electron beam interaction, and then we have our third part, that is imaging system. So where our images are formed, diffraction pattern is formed, and images are formed, and we can have the information. So again, I am going to the same slide where I was explaining about the working of TM. So as it passes down through the tube, the electron beam is controlled by electromagnetic lenses formed by coils around the tube, whose effect is moderated by adjusting the electricity flowing through the coils. These electromagnetic lenses direct the electron beam through the center of the tube to a very thin specimen located part way down to the tube. Formation of an image. So in this part, I will be explaining you how the formation of image takes place. So after passing from illumination system to objective lens, that is the heart of the TM, we have this formation of image. So I'm going to discuss about that. So formation of an image of the specimen is possible because the electrons in the beam are affected by different regions of the specimen in different ways. So first thing can happen that some part of the specimen might allow electrons to pass through unaffected. So it can happen. Maybe some electrons are unaffected and they just pass through. Second thing can happen that other regions within the specimen absorb some or all of the electrons. तो ये हो सकता है कि स्पेसिमेन कुछ इलेक्ट्रॉन्स को ऑब्जर्व करे और ये भी हो सकता है कि वो सारे इलेक्ट्रॉन्स को एब्जॉर्ब कर ले. That reach them so that fewer, if any, electrons continue from the part of the specimen further down the tube to the image formation plane, and those that do continue may do so with less energy because some of their energy has been absorbed by or passed to the part of the specimen that the electrons passed through. So anything can happen. Then third is some tiny regions of the specimen may deviate the path of the electrons, forming the beam so that electron bounce off these precise positions or areas within the specimen in a range of directions. So this can happen also. That electron का जो path है हो सकता है आपका वो deviate कर जाए और electrons जो है वो bounce हो जाए अपनी position से, उन precise position से bounce हो जाए, ये भी हो सकता है. So that is instead of either continue down the tube as in part 1 or stopping or at least slowing down or being absorbed as in part 2. तो in part 1 में था कि वो just continue कर रहे हैं ट्यूब में, डायरेक्ट निकल रहे हैं unaffected. सेकेंड पार्ट में था कि वो स्टॉप हो रहे हैं या एब्सॉर्प्शन हो रहा है या उनकी जो स्पीड कम हो रही है. अब आपका जो थर्ड पार्ट है कि सम पार्ट ऑफ द स्पेसिमेन के मे कॉज इलेक्ट्रॉन्स टू बाउंस अप इन डिफरेंट डायरेक्शन, दैट इज टू स्कैटर द इलेक्ट्रॉन. थर्ड में ये हो सकता है कि इलेक्ट्रॉन्स की स्कैटरिंग भी हो सकती है एंड दे कैन हैव इट कैन हैव इन डिफरेंट डायरेक्शन में आपकी स्कैटरिंग ये हो सकती है. तो तीनों पार्ट आपको क्लियर है. आई होप कि फर्स्ट पार्ट में या तो वो आपके सीधे डायरेक्ट निकल गया, कोई भी इफेक्ट नहीं पड़ा इलेक्ट्रॉन्स के ऊपर. सेकंड पार्ट में या तो ये एब्जॉर्ब हुए इलेक्ट्रॉन्स, कुछ एब्जॉर्ब हुए या सारे एब्जॉर्ब हुए या इनको मतलब कुछ मतलब मिला कि इनको स्लो हुई इनकी स्पीड. एंड थर्ड पार्ट में इनका जो है ये बाउंस ऑफ हो गए इन डिफरेंट डायरेक्शंस में और ये स्कैटर हो गए. So fourth part में depending on if and how they have been affected by the specimen, electrons continue down the tube through further electromagnetic lenses with a range of energies. They eventually form an image when they reach an image plane where they are detected by a suitable sensitive material such as a fluorescent film. So जो electrons आपके depending on if and how they have been affected by the specimen, इलेक्ट्रॉन्स कंटिन्यू डाउन द ट्यूब. इलेक्ट्रॉन्स आपके कंटिन्यूसली ट्यूब में आपके डाउनवर्ड डायरेक्शन की तरफ आ रहे हैं एंड थ्रू इलेक्ट्रोमैग्नेटिक लेंसेज एंड दे आर हैविंग डिफरेंट एनर्जीज एंड इवेंचुअली दे फॉर्म एन इमेज, जिससे कि एक इमेज का फॉर्मेशन होता है. और ये जिसका डिटेक्शन है इसके लिए यहाँ पे फ्लोरेसेंट आपकी फिल्म लगी है जहाँ पे इसका इमेज का आपका डिटेक्शन होता है, फॉर्मेशन वहाँ पे आपका इमेज बन के आ जाती है. So there are several similarities and differences between Sem and Tm, which I am going to discuss now. So there are a variety of similarities between the two. Both are types of electron microscope. दोनों आपके इलेक्ट्रॉन माइक्रोस्कोपी हैं. एक में जो है वो आपकी इलेक्ट्रॉन बीम, दोनों में जो सोर्स है वो इलेक्ट्रॉन सोर्स आपका इलेक्ट्रॉन बीम ही है. और जो स्कैनिंग इलेक्ट्रॉन माइक्रोस्कोप में है उसमें आपकी बीम स्कैन हो रही है सरफेस के ऊपर और ट्रांसमिशन इलेक्ट्रॉन माइक्रोस्कोपी में ट्रांसमिट हो रही है. So both are types of electron microscope and gives the possibility of seeing, studying and examining small subatomic particles or compositions of a sample. दोनों टेक्निक की हेल्प से हम देख सकते हैं, स्टडी कर सकते हैं सब एटॉमिक पार्टिकल्स को, उनके कॉम्पोजिशंस को. तो ये बहुत ही मतलब इम्पोर्टेंट है कि इनसे हम सब एटॉमिक पार्टिकल्स के बारे में जान सकते हैं. Both also use electron, specifically electron beams, the negative charge of an atom. So images produced from these instruments are highly magnified and have a high resolution. As compared to optical microscope, SEM की images more magnify होती हैं, उनका और भी उनका resolution होता है. और as compared to SEM, TM का resolution और भी ज़्यादा होता है और उनका magnification और भी ज़्यादा होता है. तो अब डिफरेंसेस भी इसके डिस्कस कर रहे हैं. द मेथड यूज्ड इन सेम इज बेस्ड ऑन स्कैटर्ड इलेक्ट्रॉन व्हाइल टीएम इज बेस्ड ऑन ट्रांसमिटेड इलेक्ट्रॉन एज इट नेम सेज. सो द स्कैटर्ड इलेक्ट्रॉन इन सेम आर क्लासिफाइड एज बैक स्कैटर्ड और सेकेंडरी इलेक्ट्रॉन. जो स्कैटर्ड इलेक्ट्रॉन है सेम में, जब सेम में आपकी इलेक्ट्रॉन बीम स्कैन कर रही है तो इसमें आपके बैक स्कैटर्ड इलेक्ट्रॉन्स भी हैं, सेकेंडरी इलेक्ट्रॉन्स भी हैं, जिनका डिफरेंस मैंने आपका लास्ट क्लास में डिस्कस किया था. So however there is no other classification of electrons in TM. TM में इस तरीके का कोई क्लासिफिकेशन नहीं है कि बैक स्कैटर्ड इलेक्ट्रॉन से सेकेंडरी इलेक्ट्रॉन से. आप उस डायग्राम से कंफ्यूज मत होइएगा. डायग्राम में ओवरऑल ऑल द सिग्नल्स दिखाए हैं which can produce when electron beam and sample interaction takes place. लेकिन सैम के केस में तो आपका बैक स्कैटर्ड और सेकेंडरी इलेक्ट्रॉन का क्लासिफिकेशन है, TM के केस में ये क्लासिफिकेशन नहीं है. The scattered electrons in SEM produces the image of the sample after the microscope collects and counts the scattered electrons. In TM, electrons are directly pointed toward the sample. So the electron that pass through the sample are the parts that are illuminated in the image. So this is the major difference. यहाँ पे तो आपकी स्कैटरिंग हो रही है, माइक्रोस्कोप स्कैटर्ड इलेक्ट्रॉन्स को कलेक्ट कर रहा है, काउंट कर रहा है, उससे इमेज का फॉर्मेशन हो रहा है. लेकिन टीएम के केस में जो इलेक्ट्रॉन्स हैं वो डायरेक्ट आपके सैंपल की तरफ जा रहे हैं और सैंपल्स में पास हो रहे हैं, जिससे कि आपकी जो इमेज का फॉर्मेशन हो रहा है. सो दैट इज व्हाई दे आर मोर मैग्नीफाइड, दे आर हैविंग मोर रेजोल्यूशन. Further, in terms of magnifications and resolution, TM has an advantage compared to SEM. TM has up to 50 million magnification level, while SEM only offers 2 million as a maximum level of magnification. So this is the difference in terms of magnification. Now in terms of resolution, the resolution of TM is 0.5 angstrom, while SEM has 0.4 nanometers. So however, SEM images have a better depth of field compared to TM product images. So these are the differences. Still some differences are there I am discussing. So in SEM, the sample is prepared on specialized aluminum stubs and placed on the bottom of the chamber of the instrument. So जैसे कि मैंने आपको SEM में बताया था, SEM में जो sample holder use करते हैं उसको stub कहते हैं और वो एल्यूमिनियम के आपके बने होते हैं जिससे हम सैंपल को प्लेस करते हैं एंड दे आर प्लेस्ड ऑन द बॉटम ऑफ द चैम्बर ऑफ द इंस्ट्रूमेंट और द इमेज ऑफ द सैंपल इज प्रोजेक्टेड ऑनटू द सीआरटी और टेलीविजन लाइक स्क्रीन, जहाँ पे आपकी जो इमेज का प्रोजेक्शन होता है. और सैम में आपकी कंडीशन होती है कि सैंपल हैज टू बी कंडक्टिव. अब ये कंडीशन यहाँ पे टीएम में नहीं है. टीएम की कंडीशन आपकी स्लाइटली डिफरेंट है. टीएम में आपका जो सैंपल है इट हैज टू बी वेरी थिन. दोनों में आपका ये वैक्यूम में ही प्रोसेस होता है. ऑन द अदर हैंड टीएम रिक्वायर्स द सैंपल्स टू बी प्रिपेयर्ड इन अ टीएम ग्रिड एंड प्लेस्ड इन द मिडिल ऑफ द स्पेशलाइज्ड चैम्बर ऑफ द माइक्रोस्कोप. So the image is produced by the microscope by fluorescent screen. So इस टर्म में थोड़ा यहाँ पे आपका डिफरेंस है. Another point of difference in the sample thickness, staining and preparation. The sample in TM is cut thinner in contrast to a SEM sample. In TM, as the electrons have to transmit through the substances, the sample thickness should be very thin to allow the electrons to pass through. अब सपोज हम थिक सैंपल यूज करेंगे तो हमारी इलेक्ट्रॉन बीम उस पर पास ही नहीं होगी. सेम के केस में इलेक्ट्रॉन बीम केवल स्कैन कर रही है सरफेस के ऊपर, इसलिए हमको जो है कंडक्टिंग सरफेस भी चाहिए वहां पर. हम उस पर जब सैंपल लेते हैं सेम का तो उसको हमको कंडक्टिंग लेयर उसके ऊपर डालनी होती है. तो कंडक्टिंग लेयर हम किसी भी मेटल की उसमें हमको डिपॉजिट करनी होती है. वो गोल्ड की हो सकती है, सिल्वर की हो सकती है. इसमें ये कंडीशन नहीं है. इसमें टीएम में आपकी जो बीम है वो ट्रांसमिट हो रही है सैंपल में. इसको थिन होना चाहिए जिससे कि इलेक्ट्रॉन बीम उसमें पास हो जाए. Coating of sample is required in the field of scanning electron microscopy to enable or improve the imaging of samples. Creating a conducting layer of metal on the sample inhibits charging, reduces thermal damage and improves the secondary electron signal required for topographic examination in the CM. That is why we have to make sample conductive in case of scanning electron microscopy. Now I am summarizing this particular lecture. Both SEM and TM are two types of electron microscope and are tools to view and examine small samples. इन दोनों टेक्निक की हेल्प से हम सैंपल को अपने एग्जामिन कर सकते हैं. अगर हमको और भी ज़्यादा रेजोल्यूशन और मैग्निफिकेशन चाहिए वी कैन यूज TM. बोथ इंस्ट्रूमेंट यूज इलेक्ट्रॉन्स और इलेक्ट्रॉन बीम. सोर्स आपका सेम है, दोनों में ही आपकी इलेक्ट्रॉन बीम यूज की जाती है. एक में स्कैटर होती है, एक में आपकी ट्रांसमिट होती है. The images produced in both tools are highly magnified and offer high resolution. How each microscope works is very different from another. दोनों की वर्किंग आपकी बिल्कुल अलग है. SEM scans the surface of the sample by releasing electrons and making the electrons bounce or scatter upon impact. The machine collects the scattered electrons and produces an image. The image is visualized on a television-like screen. On the other hand, the TM presents the sample by directing an electron beam through the sample, and this result is seen using a fluorescent screen. images are also a point of differences between two tools. SEM images are three-dimensional and are accurate representations, while TM pictures are two-dimensional and might require a little bit of interpretation. So it is easy to interpret SEM images as compared to TM images, since they are images which are produced with the help of SEM technique. They are three-dimensional, while TM produces two-dimensional image, and it might require a little bit of interpretation. It means interpretation is a little bit difficult. In terms of resolution and magnification, TM gains more advantage as compared to SEM. So this is all for today's lecture. And now if you have any kind of query, or if you want to have any discussion, you can have it. Students, please ask the questions if you have any. Any one of you, if you have any problem, you can ask.
मैम टोपोलॉजी और मॉर्फोलॉजी का डिफरेंस दीजिए.
टोपोग्राफी एंड
मॉर्फोलॉजी.
मॉर्फोलॉजी एंड टोपोग्राफी. मॉर्फोलॉजी आप जो सरफेस का आप देख रहे हैं स्ट्रक्चर, आपको कि मैं एक्सप्लेन करती हूँ ये एक स्लाइड के हेल्प से. वेट करिएगा जरा, वेट अ मिनट, मैं आपको भी एक्सप्लेन कर रही हूँ. एक और स्लाइड शेयर कर रही हूँ इसको एक्सप्लेन करने के लिए. Wait, I'll just sharing the another slide. Okay. So I'm going to explain you the difference between surface and this morphology and topography term. So surface morphology is I hope the screen is visible. Surface morphology is a subset of analytical imaging, which is an advanced form of high spatial resolution imaging that uses sophisticated microscope to produce images of products, samples and objects that cannot be seen with the naked eye. Such images originates from the exposed surface of the sample or product. Morphology is a qualitative evaluation of the three-dimensional shape of a surface, whereas topography provides quantitative feature dimensions. Morphology studies the shape, texture, and distribution of materials at a surface, whereas topography focuses on the quantitative dimensional measurement of features on a surface. So this is the major difference between morphology and topography. Morphology basically studies about this qualitative quantities and qualitative features, and by this topography means we are having quantitative data in terms of dimensional measurement or other features on a surface. So we use both terms. हम कभी morphology की भी बात करते हैं, topography की भी बात करते हैं. तो अगर हम आपसे topography के लिए कह रहे हैं, it means we are talking about quantitative measurement. अगर खाली आपकी morphology की बात हो रही है, तो morphology is the qualitative evaluation of three-dimensional shape जो हम SEM से observe करते हैं. तो उससे हम it means we are talking about morphology. और अगर हम किसी quantitative data की बात कर रहे हैं, it means we are talking about topography. So it may be It may have this dimensional measurement or other features. I hope it is clear.
Okay, ma'am.
Clear? Okay. Or any other question? Any other question if you have?
किसी स्पेसिमेन का हमें ऑब्जर्वेशन करना है तो
हाँ
तो उसका ऑपरेशन हम टैम से भी कर सकते हैं और सेम से भी कर सकते हैं।
दोनों से कर सकते हैं, दोनों से कर सकते
हैं। बट मतलब थिकनेस जो होगी, अगर सेम से कर रहे हैं तो सैंपल का थिकनेस कम होना चाहिए।
जब टीएम से कर रहे हैं तब थिकनेस कम होना चाहिए, क्योंकि इलेक्ट्रॉन बीम को ट्रांसमिट होना है उसमें।
ट्रांसमिट करना है। अच्छा।
और अगर सेम से कर रहे हैं तो इसमें तो स्कैन होके स्कैटर होना है इलेक्ट्रॉन को, तो इसमें थिन सैंपल की जरूरत नहीं है, लेकिन कंडक्टिव सैंपल की जरूरत है उसमें।
अच्छा।
दोनों के सैंपल रिक्वायरमेंट अलग है। सेम में आपको कंडक्टिव सैंपल चाहिए, तो इसके लिए आपका जब सैंपल प्रिपेयर होगा तो इसमें आपको एक एक्स्ट्रा प्रिपरेशन भी चाहिए सेम मेजरमेंट के लिए। उसके लिए आपको एक मेटेलिक मटेरियल की लेयर वहां पे डिपॉजिट करनी होगी। तो डीसी स्पटरिंग मेथड से हम उस लेयर को उसमें डिपॉजिट कर सकते हैं। तो ये गोल्ड की भी हो सकती है, सिल्वर की हो सकती है। आप डिपॉजिट करेंगे तभी उसमें आप मेजरमेंट कर पाएंगे। और टीएम के लिए जो सैंपल के टर्म में कंडीशन जरूरी है वो थिन सैंपल चाहिए। अगर आप थिक सैंपल यूज करेंगे तो आपकी जो इलेक्ट्रॉन बीम है उसमें ट्रांसमिट नहीं होगी, तो फिर हम उसमें अपना इंफॉर्मेशन कलेक्ट नहीं कर पाएंगे। बाकी आप दोनों से ही मॉर्फोलॉजी और टोपोग्राफी जो टर्म हम यूज कर रहे हैं, ये आप दोनों से ही मेजर कर सकते हैं। क्वालिटेटिव मेजरमेंट भी हो सकते हैं थ्रू मॉर्फोलॉजी, क्वांटिटेटिव मेजरमेंट भी हो सकते हैं थ्रू टोपोग्राफी।
मतलब जैसे आपने बताया कि वो अगर इलेक्ट्रॉन जो होते हैं, जैसे एल शेल से इलेक्ट्रॉन जंप करता है के शेल में और एनर्जी इमिट करता है, तो इस एनर्जी जो इमिट कर रहा है उसको ऑब्टेन मतलब एम शेल का इलेक्ट्रॉन करता है कि मतलब के शेल का ही इलेक्ट्रॉन कोई करेगा?
नहीं, उसमें ये हो सकता है ना कि आपका एल शेल का इलेक्ट्रॉन भी तो कर सकता है। उसको जो एनर्जी वहां से रिलीज हो रही है, जो एल शेल में नेक्स्ट इलेक्ट्रॉन है आपका, उसको ये एनर्जी इम्पार्ट हो सकती है, तो उसको इनफ एनर्जी मिल जाएगी। हाँ, जैसे आपका के से पहले एल में गया, ठीक है, के शेल को एनर्जी मिली और वो एल में गया, तो के में आपका होल क्रिएट हो गया। तो एल में इमीडिएटली क्या होगा, एल से एक इलेक्ट्रॉन जो है वो के शेल की वैकेंसी को फिल करने के लिए के शेल की तरफ मूव करेगा, तो उस प्रोसेस में आपकी एनर्जी रिलीज होगी। तो वो एनर्जी जो है, वो जो ओजे इलेक्ट्रॉन की हम बात कर रहे हैं, अगर वो एनर्जी एल शेल के ही दूसरे इलेक्ट्रॉन को इम्पार्ट हो जाती है, ट्रांसफर हो जाती है, तो उसके पास सफिशिएंट एनर्जी होती है एस्केप करने के लिए, वो एस्केप कर सकता है। और कोई क्वेश्चन है आपका?
नो।
धीरेन्द्र, और कुछ पूछना है आपको?
नो मैम।
Any question? Any other question? काजल, आपको पूछना है कोई क्वेश्चन? काजल, अनुराधा, कमल, और किसी का कोई क्वेश्चन है तो प्लीज पूछिए। Is there any other question, or I should stop now? Okay, then please leave.
Thank you, ma'am.
Okay, and I will be sharing the PDF of this PPT.